Now, unfortunately, squaring the exponent 2 is not the only exponent that exists in math. You all know exponents can be any size. So not only can we do a square root, we can do other roots. And that's what we have to keep discussing. So let's go and look at another root. So if you go to your notes, let's go to the operation cubing. Cubing means you're multiplying something 3 times. We've already seen this list when we did difference and sum of perfect cubes in factoring. So we're going to understand that if you can cube a number, you could do its opposite, cube root. Again, to do a cube root, you got to know what numbers are perfect cubes. So let's go to the board and list our numbers that are perfect cubes. So, what number we're going to multiply 3 times to give us a perfect cube? The first perfect cube, obviously, is the number 1. Because 1 times 1 times 1 is 1. The next perfect cube is 2 times 2 times 2, which is 8. 3 times 3 times 3, which is 27. 4 times 4 times 4, which is 64. 5 times 5 times 5, 125. 6 times 6 times 6, 216. 7 times 7 times 7, 343. 8 times 8 times 8, 512. 9 times 9 times 9, 729. 10 times 10 times 10, 1,000. These numbers can all be written with exponents of 3. For example, you all know 8 really is 2 times 2 times 2. We could write that as 2 cubed. Now, if that's an exponent of 3, it has an opposite. If I call that cubing, the opposite cannot be square root. The opposite would be a cube root. And the difference between a square root and a cube root is putting this little 3 there. When you put that index of 3, that means cube root. So if I wrote cube root of 8, I'm asking you, what number do you multiply 3 times to give you 8? And we know that's the number 2, because 2 times 2 times 2 was 8. So you can cube root any number that's a perfect cube. Therefore, by knowing this list, there's no work. So let's go to our examples in our notes. All right, so let's look. The cube root of 27, there's no work. What number do you multiply 3 times to give you 27? That's 3. The cube root of 64, there is no work. What number do you multiply 3 times to give you 64? That's 4. Cube root of 1. What number do you multiply 3 times to give you 1? That's 1. Now, everybody look very closely at example 6. That says cube root of -8. That is asking you what number can you multiply 3 times to give you -8. That has an answer. Let's go to the board. If I write cube root of -8, what number can you multiply 3 times to give you -8? That is the number -2. I will prove it to you. If you take -2 and multiply it to itself 3 times, that's what cubing means, 3 times. A negative times a negative is a positive. A positive times a negative is a negative. And 2 times 2 times 2 is 8. So you got to make a special note that cube roots, you can do a cube root of a negative number. You just can't do a square root of a negative number. So you got to pay close attention to the index. If it's cube roots, you can do a negative number. Now, here's our problem. Who says exponents are just size 2 and 3? Who says you can just square a number and cube a number? You can do any size exponent. Therefore, roots have no end. You can do a square root, a cube root, a fourth root, a fifth root, a sixth root, a seventh root, and on and on and on. The concept is the same. Roots means multiplying the same number so many times. Square root means to multiply a number 2 times. Cube root means to multiply the same number 3 times. So now let's look at our notes and look at some other roots. So if we go to our notes here, if you look at the indexes. They're 4s, 5s, and 6s. I'm asking you to do 4th roots, 5th roots, and 6th roots. Now that we don't got to make a huge list, we just got to understand the concept. The 4th root of 16 means what number do I multiply 4 times that can give me 16? Well, could it be 1 times 1 times 1 times 1? Nope, that's a 1. But can it be 2 times 2 times 2 times 2? Sure it can. So the fourth root of 16 is 2. If you look at example 3, that is the fifth root of 1. What number can you multiply 5 times that makes 1? Well, that's obvious. That's a 1. If you look at example 5, that's the sixth root of 64. So let's go to the board and look at that. So even though I'm not going to make a list of all the numbers that you'd multiply 6 times, let's think about this. The sixth root of 64 means what number can I multiply 6 times to give me 64? You could either sit here all day and go 1 times 1 times 1 times 1 times 1 times 1, 2 times 2 times 2 times 2 times 2 times 2 till you get it. Or you can sit over here and do a factor trade. You can actually break this down and figure out what number multiplies 6 times to give you 64. So I know 64 is 8 times 8, but that's only 2 numbers. 6 root means I need 6 numbers. 8 is 2 and 4. 4 is 2 and 2. That's 3 numbers. 8 is 2 and 4. 4 is 2 and 2. Well, now it's obvious. If I take the number 2 and multiply it 6 times, I would get 64. So when I ask you this, the sixth root of 64, that's what I'm asking you. What number do you multiply 6 times that would give you 64? It is 2. Now, if you look at example 7, that says the sixth root of negative 64. Can you multiply the same number 6 times to get a negative 64? There's no way. Even if you put a negative out 6 times, a negative times a negative is a positive, a negative times a negative is a positive, a negative times a negative is a positive. There is no way to multiply a number 6 times to make a negative 64. So we say the answer is, if you can't do it, no real root. Okay, next video I see you on, we'll be doing this with algebra. Have a good day.